Okay, so in this short capsule, we'll look at Lewis dot structures of these three different compounds. The molecular formula MF, molecular formula is given here. The first one is C2H6, second one is CH4O, third one is CH5N. So in the previous short capsule, we introduced Lewis dot structures and figured out how to draw a structure for a given molecular formula. Today we are doing more examples of the same. So let's start with the first one, C2H6. So there are 2 carbons, 6 hydrogens, and here at the top of the screen you have I have written down the electronic configuration of these 3 atoms, carbon, nitrogen and oxygen. So carbon, there are 6 electrons in carbon. The electron configuration is 1s2, 2s2, 2p2. Nitrogen has 7 electrons, that's the electronic configuration there. And oxygen has 8 electrons, that's the electronic configuration there of carbon, nitrogen and oxygen. So you notice that the 1s shell is full, so that is the core shell. In the second shell, electrons in the second shell for these atoms, they are the outermost shell. Second shell is the outermost shell, the electrons there are the outermost electrons, so they are called the valence electrons. So we need to look at only the valence electrons when we look at this, drawing this Lewis dot structure. So carbon, each carbon has 4 electrons, 2 electrons in the second shell, 2 electrons in the p shell, p orbital, sorry, s orbital and p orbital. So each carbon atom has 4 valence electrons. So there are 2 carbon atoms, so there are 8 valence electrons in the supply, that's a supply from carbon, and each hydrogen atom has 1 electron, so there are 6 total, so the supply is 14 electrons. Now the demand, remember these atoms, carbon, nitrogen, oxygen, fluorine and boron, they demand an octet, a set of 8 electrons, that's octet rule. They demand 8 electrons around themselves. So each carbon atom demands 8 electrons. So there are 2 carbon atoms, so 8 times 2 is 16. Similarly, hydrogen atom requires 2 electrons around itself, so it becomes like helium and then it's heavy. So each hydrogen atom requires 2 electrons. There are 6 hydrogen atoms, so totally 12 electrons. So the demand is 28 electrons. I tend to do that. 16 electrons, 28 electrons. So now, how many bonds will be there to satisfy this molecular formula and all these constraints? So 28, so this is the formula to determine the number of bonds in a given molecule. Demand minus supply by 2. So demand is 28 for C2H6, supply is 16, so and that divide that by 2, so you get 6 bonds. Okay, so we'll draw the structures shortly for C2H6, but notice, let's keep that there, 6 bonds. So let's do the similar exercise for CH4 and CH5N. CH4 carbon has 4 electrons, 4 electrons coming from 4 hydrogen atoms, and oxygen has 6 valence electrons. So totally the supply is 14 electrons. And moving down further, carbon 4, hydrogen 5, nitrogen 5 electrons. So the total is 14 electrons. Okay. So what about the demand? Carbon demands 8 electrons around itself. There are 4 hydrogen atoms. They will demand 4 times 2, 8 electrons. And oxygen demands 8 electrons, so 24 electrons. And CH5N, carbon demands 8 electrons, the octet. 5 hydrogens demand 10 electrons, and nitrogen demands 8 electrons, so 26 electrons here. So solving for number of bonds, so for CH4O it is 24 minus 14 by 2 equals 10 by 2 equals 5 bonds. So there are 6 bonds for C2H6. CH4O has 5 bonds, and CH5N will have 26 minus 14 by 2 equals 6 bonds. Okay. So let's keep this in one corner so we do not forget this, because I need to erase all this. So C2H6 has 6 bonds, CH4O has 5 bonds, and CH5N has 6 bonds. Now I need to erase this so we can draw those dot structures. So let's start with C2H6. Now when we draw Lewis dot structures, we focus on the atom. So we need to find out which atom will be in the center, right? There are 2 carbons and each carbon will have like 4 bonds. So we put carbons in the center. You cannot put hydrogens in the center really, because hydrogen can form only 1 bond. So put a carbon in the center. Let's say carbon 1, and carbon 1 is bonded to carbon 2. So you see 1 bond, so there. Now you notice it's empty, not empty, it's incomplete. So we need to bring in the hydrogens. So the hydrogens are coming in 1, 2, 3, 4, 5, 6. So this is the Lewis dot structure for this molecule. Incidentally, this molecule is called ethane. Last time, the Lewis dot structures 1 video, we looked at the structure of CH4, which is methane. Okay. Notice there's some similarity here, CH4, methane, C2H6, ethane. So you are seeing some where I'm just bringing this up because later on when we talk about naming this compound, this sort of suffix, ane, they mean something in naming. So anyway, coming back to this, we will have, notice this carbon has 8 electrons around itself, and this carbon has 8 electrons around itself, like this. Okay. So both carbons have an octet, and each of the hydrogen atoms have a duet, 2 electrons around it. So this is a good structure. Every atom has the electrons that it needs to be happy. So this one can be collapsed to structures like this. So this is how we write them. C2H6. So this is good. This is done. So we'll do one more, and then you work on the remaining one. So let's say which one we want. Let's go with the nitrogen one. Nitrogen 1, CH5N, CH5N. Okay. So again, make a judgment whether you want carbon, hydrogen, nitrogen. Carbon forms 4 bonds, hydrogen forms 1 bond, nitrogen forms 3 bonds. So it makes sense to start carbon. And carbon is bonded to nitrogen. Maybe I need to bring another color or not. So the nitrogen, remember nitrogen has 5 valence electrons. So I'm putting, let me bring another color just clear. So I'm using the red color to bring nitrogen's electrons here. So there are 3 electrons on the nitrogen, and then there are 2 more. We'll come to that. We can put 2 more there. And then that is the 5 electrons from nitrogen. And then there are 5 hydrogen atoms. Let's see, we use a blue for hydrogen electrons. So there's 1 hydrogen there, another hydrogen atom, another hydrogen atom, another hydrogen atom, another hydrogen atom. Now, you see, these 2 electrons, that's already paired, so it's there. Now, if you look at this, the nitrogen atom has its octet, 8 electrons around the nitrogen atom, and carbon also has an octet like this. The carbon is also happy, it has 8 electrons, nitrogen has 8 electrons. So now if we transfer that, translate that into a structure like this, you draw it like this, and notice this, a pair of electrons on nitrogen, they are not bond pairs. See, this is a bond pair, this is a bond pair, that is a bond pair. They're involved, those 2 electrons are involved in making bonds. So like this one, those 2 electrons are involved in making bonds. These 2 electrons are involved in making bond. But these electrons here, they're not involved in a bond. They are called the lone pair. The lone pair of electrons. This is very important in organic. Nitrogen atom, a neutral, notice there's no charge on these atoms, which will be our next video, Lewis dot substance 3. No charge on this, it's a neutral compound. Nitrogen has a lone pair, and that lone pair can be used, will be used, when necessary to react with others. So we'll come to that, in future videos, but make this distinction. There's a lone pair on nitrogen. Okay. Now, I'll just show you the structure of CH4O, and you complete practice this. Try to get the structure on your own, and you will notice that there will be 2 lone pairs on oxygen. Okay. Practice this on your own. If not, we'll see what to do about it. Okay, we'll stop here.